In my opinion, good quality code design is one of the most important parts of long-term projects in almost any game engine, which is why I'm surprised to see how little it's actually covered in beginner's tutorials. A lot of people's first programming experience will be with game development. This is just plain not a good way to do things. To learn game programming, you have to know some things about regular programming. Since this video is going to cover game programming patterns, if you're still not quite sure what a variable or a function is, I recommend messing around in an easy to learn language with no boilerplate code like Python. Although, don't worry if you're a complete novice, I will explain some of the coding fundamentals needed to understand this video. The last important thing that you should do is to understand object-oriented programming and get closer to Unity, which is the engine I will be discussing in this video. I recommend this C# tutorial series from Brackeys. It will teach you pretty much all of the C# basics you will need to know before tackling game engine specific features, and it has a very comprehensible explanation of how and why you should be using these language features. I'm going to put some explanations of some terms I'll use in this video, and some side tips related to them on screen for complete novices on the subject who want to keep up with the video. Now, to tackle the core theme of this video, I'm going to begin by talking about the Unity event. This little thing is a neat way to decouple classes in your game, and I'll explain what this actually means in a moment, so don't worry if that flew right over your head. When creating some sort of link between two objects in your Unity project, say you want a lever to open a door when the player interacts with it, your first temptation might be to make a public variable to which you can assign your door script in the editor, and then call the open function in your lever's code. The problem with this solution arises when you suddenly want your lever to raise a platform lift instead, and of course the class for your lift is different to the class for your door, so you need to add some sort of public boolean to check which function to call, otherwise you get an error, and then you might want to be able to call multiple functions with one lever press, or even have a lever that just does nothing at all. This is a guaranteed way to make a mess of your code. Your spaghetti is going to get tangled even more tightly as it becomes harder to track what is done where, which paths change important states or variables and which don't, making adding even more functionality to your code later down the line a huge pain in the ass. The best way to handle a situation like this is by using a Unity event. You can create one in your script by simply typing this, and then you can add functions to it like this, and you can invoke it like this. A Unity event can practically be seen as a sort of modular function that calls all functions that you attach to it. However, the genius comes not in the code editor, but actually in the inspector window. If you made your Unity event public, you can now select any script in the scene and set your event to call a function in that script when it is invoked. You can add any number of functions from your scene, both custom ones and those that are already part of Unity's components, such as playing an audio source. Now, literally any function in your game can be called by this lever prefab, allowing for much quicker level design, prototyping, and experimentation with various elements of your game. Another similar example for why the Unity event is so good is actually in the interact prompt for this lever. Now for this lever, the interact prompt is actually woven directly into a script, meaning if we want to say create some other interactable object in our game like a pickup, then we have to rewrite this code in the pickup script as well. By making the interact prompt and interactable zone a separate object and giving it its own script with a Unity event in it, it's now easy for us to make any object or area in our game interactable. The design philosophy you should be learning from these examples is that most of the time you are making tools to make your game. A good tool is adaptable and quick when implementing new ideas and sticks to consistent rules. You want to make sure you have to code as little exceptions to your rules as possible, and once you have too many, your project will feel cluttered and difficult to manage. Another thing I want to draw attention to is the way jump inputs are handled in this script. Whenever a jump is input by the player, a short timer with the same duration as the Coyote timer starts counting. And during that time, if the player is grounded, they will perform a jump in case they press the jump button right before they hit the ground. Now what a lot of people will do, and what I used to do, is in this onJump function, I would check if the player is grounded at that moment, and if so, jump right away there and then, and otherwise start ticking the timer down. But instead, I chose to make it so that no matter what the player's current state is, I will always start ticking the timer down. This was to avoid unnecessary divergences in the code flow. There is absolutely no practical reason to copy the jumping code into here and have two separate instances of it that will both need to be updated if I make changes to the jump. This way, jump input will always predictably flow through the jump queue timer variable, meaning my code will consistently run through this single point here every time the player jumps, making modifications to the jumping logic very easy. The key takeaway for this video is to make your code adaptable and also consistent. Hopefully the techniques and examples I have provided will help you to develop your own understanding of how to pull this off in your code for your project, and stop you from getting burnt out on longer projects. Good luck, and goodbye.